Welcome back, everybody. Today we're talking about Natural Wonders Chapter 3, which is another chapter of minerals. All right, so there's not really any extra information to get into, no extra paragraphs to talk about, so just make sure you have your Natural Wonders packet in front of you, and let's take some notes and let's get to it. The very first mineral is biotite, and biotite is one of the two minerals that peel into thin sheets. So as you watch this mineral, you're going to see it rotate, and when you get that nice side view, it almost looks like an encyclopedia, like just a really thick textbook. Okay, and those textbook pages, they peel apart just like an encyclopedia would. I actually call a big chunk of biotite a book of biotite. The second mineral is my favorite, quartz. All right, we have two samples of quartz. One is just what we call like massive quartz, and the other one is some amethyst quartz crystals, okay, in a geode, which is pretty cool. Okay, and quartz is the second most common mineral in Earth's crust. So it's one of the top two most common minerals in Earth's crust. The third mineral is olivine. And olivine looks like a massive green sand grains. That's how you're going to see it described. And that's because this mineral, olivine, is used to being underneath the crust. Okay, so it comes from deep inside the earth in the mantle. And so it's used to having this confining force squeezing on it. And when it makes it to the surface, that confining force releases. And so the mineral actually expands, and as it expands, it cracks. And that's what produces that sand grain look to olivine. After olivine, we have hornblend. Okay, hornblend is a really dark colored mineral. It has kind of these elongated crystals. As you see it rotate, you'll see that shine showing the elongated crystals. Okay, and hornblend is found in granite. Okay, so it's a common mineral in granite. After hornblend, we have muscovite. Okay, muscovite is the other mineral that peels into thin sheets. And as this one rotates around, you'll see very similar kind of book of muscovite as we saw with the biotite, but in this case, it's clear. This stuff can be transparent, like you can see right through it, so it's pretty neat. After muscovite, there's almandine. Okay, and almandine is this really almost ruby red mineral that the sample you see, once you see the light hit it just the right way, you can kind of imagine this being cut and polished into some really nice jewelry, and that's one of the uses of it. The next mineral is feldspar. Okay, feldspar is the most common mineral in Earth's crust. So the two most common would be feldspar and then quartz. Feldspar has really good cleavage in two directions. So as the mineral rotates, you're going to see these flat surfaces, and that represents the cleavage. The next mineral is gypsum. Okay, and gypsum has kind of a special place in my heart, and that's just because there's gypsum mines right here in Grand Rapids. I know when I was a kid in elementary school back at Jamestown, they used to take our entire class to a field trip to the gypsum mines. It was probably the first place I started collecting minerals. I remember running around kind of in the dark and having just handfuls of gypsum when I left. Okay, but gypsum's really special because it forms in a shallow, evaporating ocean, a warm, shallow sea. Okay, and that's right, like I'm talking about Michigan when I say a low, like shallow sea. Okay, and it just tells us a little bit about Michigan's geologic past, which is really interesting to me. Okay, not only do we have gypsum that is evidence for this warm, shallow sea, but then you have to think about our state rock. Like, did you know we have a state rock? It's a Petoskey stone. Petoskey stones used to be coral, like coral reefs. And guess where they grow? A warm, shallow, evaporating sea. Okay, we also have tons and tons of fossils. All sorts of marine organisms can be found in limestone layers, especially I'm thinking of some layers that are right on the coast of Lake Superior. Okay, so all of these factors combined give us really overwhelming evidence that Michigan was covered by an ocean. The next mineral is calcite, and the sample that you're seeing on the screen does a really good job at showing rhombohedral cleavage. Okay, I'm talking about a rhombus, right? We know a square is a square, but a rhombus is kind of like a square that's kind of squished over. Okay, that's what the side of calcite looks like. That's the type of cleavage it has. That's the way it breaks. Okay, and that's one way we can tell it apart from another mineral we'll see, halite. Halite has cubic cleavage, So it breaks along these 90-degree corners, flat surfaces. And calcite doesn't break into a square, it breaks into a rhombus, okay? And you are gonna have to know a few other ways that we can tell calcite from halite. Okay, another easy way to tell calcite from halite is the fact that calcite reacts with acid. So when you put a drop of acid on the surface of calcite, it's going to fizz and release actually CO2 gas. Okay, those are the bubbles that are coming out of that acid. The calcite, CaCO3, calcium carbonate, reacts with the acid and releases CO2. Another way to tell calcite from halite is that calcite has this really cool property called double refraction. So you're going to see that if you put a piece of calcite over a line, it's going to make that line double. It's going to make it look like two, double refraction. And the very last way that we could tell calcite from halite is because calcite fluoresces with UV light. Okay, it turns some pretty cool colors, and halite does not. Okay, so make sure you write that stuff down, you underline that, the different ways to tell calcite from halite. Next mineral is fluorite. Okay, and fluorite's really cool. I love that it has these like naturally growing cubes in nature. Okay, it has cubic crystals, and that's what we're seeing rotate on the screen in front of you. Okay, I also love the variety of colors we have with fluorite. It can be that really bright green to really dark purples to clear. Has some really cool varieties out there to fluorite. After that is halite. So halite is a mineral we talked about that sometimes can be confused with calcite. But there's really one easy test you can do. You can pick up halite, and if you taste it, that's right, like lick it, it'll taste salty. Halite is table salt. It's sodium and chlorine. After halite, there's pyrite. And pyrite is often referred to as fool's gold. So this is the one where if you go on like a family trip, you might see a bin of minerals, and this one's the one that's called fool's gold. And sometimes those pyrite crystals can be found in a mineral we saw last week, chalcopyrite. Okay, that is everything for chapter 3. Make sure you review your focus questions, and if something doesn't make sense, make sure you ask. All right, have a good day. See ya.